Hello everyone. Welcome back to the mechanics of materials. And in this video, I'm going to show you the force calculation. And last time we show how to use how to make the addition of force vector, and we use the systematic method. Okay, and this method, first of all, you need to draw a parallelogram of these two force vectors and then find a triangle, use the trigonometry to find the resultant of force. Okay. And this example is just a reverse. Okay, suppose I give you a force vectors and I want to decompose these force vector into the u direction and v direction. Okay, and de- simply speaking, just decompose the force vectors. Okay, because two vector add together can become the other vector. So in other way, a vector can be decomposed to the two vectors. Okay, so it just reverse calculations. And when it comes to the force vector decomposition, I think in your high school, okay, and maybe in high school, okay, if I have a force vector and if I have xy coordinate, okay, maybe it's not very accurate. You have a xy coordinate. You think the force vector decomposition is very easy, right? Okay, we just this component x component and y component, okay, and fx component is equal to the magnitude of force vector times cosine theta, and y component of force vector is equal to the magnitude of force times sine theta. Okay, that's maybe in high school you try to decompose the force vectors. Okay, but that's because it's easy because this x, y are orthogonal. Okay, orthogonal. Okay, x and y are orthogonal. Okay, because this coordinate they are orthogonal to each other. Orthogonal, the other word is perpendicular 垂直. Okay, x, y 垂直 perpendicular to each other. So the force decomposition is very easy. But sometimes the force decomposition not 100% in the xy, okay, xy coordinate. Okay. For example, this problem, this problem wants you to do the force vector decomposition of this force vector into this direction and this direction, u direction and v direction, and very clearly, these two directions they are not orthogonal to each other. Okay, if these two directions are not orthogonal to each other, and you want to use this decomposition method, that would be very. I'm not say it's not doable, but it will take a very long time. Okay, so when you do a force decomposition on a non-orthogonal coordinate or orthogonal directions, okay, so yeah, non non not orthogonal coordinate. Okay, so yeah, we should use this analysis. Just that we use the strategy, and the strategy is the same as we did in the finding a resultant force vector. Yeah, the same strategy. Draw a parallelogram and find a triangle and use a trigonometry to solve the x component to decompose the force. And in the force decompose problem, most of the time, yeah, just determine the magnitude of this component. Okay, yeah, that's a good thing. You just want to find, okay, decompose the force, okay, and then just find the magnitude of this component. Okay, that's very good. Okay, because direction we already know. Just want to find a component. Okay, so for this problem, okay, we just draw a simplified figure. Okay, suppose I have this is a force vector 600 Newton, and want to decompose to u direction and v direction. Okay, so so let's see. Do we have any? Let's see. Okay, this is the top, and this is okay. And let me clear. This is a straight line, and this is also a straight line. Okay, and this is a straight line, and this is also a straight line. Okay, and this is 30 degree here, and 30 degree here. Okay, so find the decompose the force. Okay, first we can draw. We say the same. We draw a parallelogram. Okay, where is the parallelogram? Okay. So let's see. Okay, so here I think it should be. Maybe this is a little too long. Okay, let me reduce this a little bit. Maybe it's not that long. Maybe it's here. Okay, this is V. Okay, let's draw a parallelogram. First of all, this V direction, the vector is here, and the U, I use the green. I think it's here. Okay. Okay, so we have a parallelogram. Okay, and next is using the uh, trigonometry. Okay, for like trigonometry. Okay, so which triangle we want to use? Okay, let's see. I think we choose this one. We choose this one. Okay, for this one we have the the 600 Newton here, and this is this is a U, so I call it FU, and this purple here is purple, and this purple, yeah, purple is here, and this purple is because this purple is parallel to V, so this is FV. Okay, and then we have an angle here. It's called 30 degree. 30 degree. Okay, so we choose this. We choose this triangle is a trigonometry. And for trigonometry, first of all, I will use the sine law because sine law looks much easy to use. So let's try the sine law first. For a sine law, you need three angles in the size. Okay, so okay, so let's list the sine law first. For sine law, you need okay, let's see, it's angle 1 here, angle 2 here, because it's 30 degree, we already know. So for the sine law, FV of the opposite angle is here, so it's sine 30 degree equal to, yeah. And FU, the opposite angle, FU is here, be careful. FU is here, the opposite angle is angle 1, okay? FU, it's opposite angle, 对角, opposite angle, FU is here, 对角 is angle 1, so it's sine angle 1. And finally, the resulting force is 600 Newton. Its opposite angle is angle 2, so it's sine angle 2. Okay, so so we need to find V and U. Okay, so if one is want to solve V, the magnitude of V component and U component, so we need to know at least. I think we should figure out the angle 2. Okay, if we know angle 2, we have this value, and and then we can find the FV. Okay, the magnitude, FV magnitude, and we can with a little further because we already know the angle 2 and 30 degree, and then we must know the angle 1 and then solve the FU out. Okay, so the criteria is okay, find the angle 2. So what is the angle 2? Do we have any information about the angle 2? Yeah, this is a geometry problem. Okay, let me see. This is a straight line. This is a straight line. So here is 180 degrees. So this must be 120 degree. Okay, and then since this is parallel, okay, what information we have? Do we have any further information? Okay, so this is also 30 degree. Okay, because this cross each other, so 30 degree here, 30 degree must be here. So this 30 degree, it tell you this must be 30 degree as well. Okay, because I'm not sure you see it or not, because let me draw it again. So it's the parallelogram. Parallelogram. Okay, so this is 30 degrees, so this must be also 30 degree, right? Parallelogram. Okay, remember parallelogram, the correct. Okay, if you don't know, yeah, just find a math book on junior high school. Okay, 30 degree here, so it must 30 degree here. Okay, so we have 30 degrees, 30 degrees. So this is a triangle. So angle two is 30 degrees. So and then angle one must be 120 degree. Did I calculate it right? Let me let me see my notes. Mhm, mhm. So FV 600 sine 600. Okay, so it's good. So angle 2 is 30 degree, angle 1 is 100, and angle 1 is 120 degree. So we just put everything in together. So this is, yeah, we can finally figure out the answer. Okay, so let me see. So this is sine what's that? Angle one, yes, 600 is sorry, 600. Angle two is 30 degree. This is 120 degree. Okay, so you can figure that out. I think I won't do this calculation in detail. Just use your calculator to figure out FU and FV. So FV should be 600, and unit is Newton, and FU is 1039 Newton. Okay, let me use my calculator to check it out. Okay. Mm-hmm. And okay, okay, so that's good. Okay, so once again, for the force decomposition, especially force decomposition in non-orthogonal coordinate, yep, just using the way we just did in the finite resultant force. Okay, just draw a parallelogram, and then using the trigonometry to figure out the force component, especially in the magnitude of force component. Okay, it's not very difficult, but you need to find the angle by yourself. I think that's the most difficult part. Find the angle by yourself. Nobody can help you. Okay. Okay. So that's an example for the decomposition of force. Okay, and see you in the next video. Bye bye. Okay. Mhm.